Fine. So last time we discussed about the creation of process and the different options actually we discussed. So to have a quick recap of that, let me say, for example, parent and select the call we have used is the fork, and there is a parent and child relationship, which actually gets a tree of processes. Now, regarding resource sharing, parent and child share all resources or no resources or subset of resources. Now, if you think of fork, I can say it is subset of resources because the text area is definitely shared, but it is duplicate copy, so each and everything will be separate. Okay. Only thing is the read portion of memory will be shared. Regarding execution, actually they execute concurrently because even we saw that sometimes parent is scheduled first and sometimes the children's are scheduled first. So it all depends. So they actually execute concurrently. And regarding waiting, what we see by default, parent don't wait for child to finish. For that, we need to use the wait call. Okay. So let me share the last time's program. Fine. So is visible? Can you see my fork.c? Yes, yes. Okay, okay. So I think this was the program we executed last time. Here we created the process and return value. Okay, so we did something like return value. So what I'll do is I'll just have a quick poll on now respond to this poll. The question is if fork returns 0, what is its meaning? Total 103 students are there. Now I'm closing the poll. So last 15 seconds. Okay, that's it. Now I just published the result of poll. So option I have given A error 11% saying it's error. 4 returns 0 for parent process. 36% of the students are saying that. And child process 23%. And there is no answer from 30%. So 30% students have not responded. Now who have not responded will go through it. But then the thing is, that is the reason purposefully I deleted something. Now on line number 14, I just check something. If CHPID equals 0, and when you see the code written there, it is the child process and not the parent. But still, there are 36%, so 37 students are there. They are saying it is a parent process. No, so answer is wrong. Child process is the correct answer. Remember what I mentioned in previous lecture also. Fork is a call invoked only once and it will return twice. Okay. So of course, if it is successful, then two different values. If it is not successful, then it returns negative value. So error, yes, fine. If it is a negative, then error. Now what are remaining two? It could be any positive number. That is the process ID for child process. And if it is 0, remember it is a child process. So if child process is executing, it will definitely get value of that as a 0. And for a parent process, it is PID of child process. Still I wonder why 36% of the students are saying it's a parent process. So I mentioned here, if it is a 0, it is a child process. Positive, it is PID of child. This is for a parent process. And if it is negative value, that means there is error while executing fork. Do you have any doubts on this code? Because again, I really wonder looking at the answer. I'll move it to right. ls4.c desktop OS. I actually forget where I saved this. ls4.c. I think it's there. Let me just see the contents of that. fork.c. Yes, this is the file. Now if I execute it, so let me compile it. clang fork.c. and execute it. Yes, so two things, very important. Number one, fork. Number two, I mentioned exe CLP. It is not just CLP. It is a family of calls. And third important thing is wait. 1, 2, and 3. Where what are the other options available here? EXE. So actually it is called as a exec family. So for example, if I open the manual page for exec from, I guess, number 3. Yes. So EXECL, EXECLE, EXECLP, EXECV, CVP, right? Now let me explain. Exec, EXEC, meaning of this is replace the in-memory copy of process that is used to execute a file. The important thing is from C language, again you can make use of system command, system, SYSTEM, that will execute the command and it will proceed further. Okay, but the thing is, whenever you make use of exec, it will replace the copy from the memory. Now, why multiple functions are available there? Fine. Let us first of all talk about EXECL. When you make use of EXECL, what happens is, even for that, what you should know is, let me hide this, and suppose you have command line arguments here, command line arguments. So what are the valid declarations for main? We usually write something like this. This is one thing. Second thing is we write like this, int argc, comma character star argv, which I use here. This is also valid. And third one is something like this, character star argv. In addition to this, character star arg, let me call this data just mv, like that. Okay. So fine. This is as well saying void. So this is no command line arguments. Fine. Here we are passing command line arguments, and here also we are passing command line arguments. In addition to that, we are passing environmental variables. Now, what are these environmental variables? We are aware the path environmental variable is there. For example, on Linux, if you just give the command env, you will get list of environmental variables. For example, here my environmental variables are shell. Now, which shell I am using? Color term, XPC flag. So, I mean, like, what is my home directory? What is log name? What is my present working directory? Which terminal I am using? What is the name of user? What is my prompt string? What is the current path? Okay. All the working directory also there. Fine. So now the thing is, these all environmental variables are made available whenever you execute the program. See, for example, something like this. So when I say /a.out, and if I pass something like 12, 13, 14, something, I'll say 12, 13, and if I press enter, then let me tell you, very first thing, a.out, this is actually the name of a process, name of executable file, which itself is first parameter for a command line argument. This is second parameter, and this is the third parameter. Okay. In addition to this, if you want to make available all these environmental variables also, then the thing is you need to use this one, additional. Okay. Uh, Somebody has raised hand. Anup Patil, I guess. You want to ask anything? Go ahead. Anup Patil. Okay, there is a question on chat. If it returns another value, that means the parent process is running and child is running at zero. Uh, Child is running at zero. I don't know what do you mean by that. The thing is the value of that variable will be zero for child process and value of that variable will be some positive value for the parent process. So in program, you can actually check the value like on line number 19 here. If it is zero, because anyway, this line number 19 will be executed by both, by parent process also, by child process also. But here what will happen, for a parent process, this condition become false. So parent will go to the else part. Whereas this condition becomes true for child process. So that is the way of how you can separate the code for parent and child. Otherwise, below fork, whatever you mention will be executed by both. Now, only thing is, it is like we are using conditional. Okay, so that is the meaning. Okay, single variable I can say, but values are different because they are stored at two different things. Two different blocks of memory are there because we have two separate processes. Is that clear? Yes. Shall we move? Fine. Fine. So let us move to. Let me going back to the terminal. I was just talking about here. So first one, EXECL, meaning of that is just execute. And this L actually stands for the arguments are given separately. So like for example, remember we need to provide a path here. Try to understand the path and file. Okay. If I say just cal command, cal. Okay. So that is the name of a file. But when I say it is user bin cal /user /bin /cal, that is called as a path. That is difference between path and file. So for EXECL, it needs path, not just name of file. Whenever P is attached, say for example here P is attached, CLP, exe CLP, here it is also EXECVP, right? Even P is also here. Extended path is also possible here. Okay, so with P, meaning of that is path environmental variable will be available with my exec family call. So automatically it will locate. So no need to provide path. So if you see whenever P is there, there is a file. Whenever P is there, there is a file. And whenever P is not there, there is a path. Okay, that is the only difference. Okay. So CLE, whenever E is attached, meaning of that is environmental variables will be also available. Okay, so that is what the environmental variables are there. So it is this, and anyways that is optional. So first of all we'll give path, whatever the number of arguments are there. Remember here for EXECL, the last argument is character star 0, and character star 0 is nothing but convert 0 to pointer, and this pointer is null pointer. This pointer is null pointer. So you just mention 0 there, no issues, that will be executed. So long listing is given actually of arguments. Now next is EXECLE, yes, environmental variable. So in addition, after this end of arguments, what we provide is list of environmental variables. Okay, and that we cannot modify. That is the reason it is a const. Next is CLP. Now, what is difference between CLP and CLP? Both are exactly same, except we just give name of file and not complete path. Now, when it comes to V actually stands for the vector, and vector is nothing but array. So rather than providing each and every argument separately as a character pointer, we have the array of character pointer. Exactly same, we pass command line arguments. Got it? So that is the way. That is the way. And again, same thing. Whenever you attach P to that also, then no need to provide the path. It will automatically take file. So that is the difference. And with CVP user defined path also you can provide. Okay. So search path you can actually provide. For example, this is typically required if that executable file is user defined file and it is not available in the path environmental variable. Then you can provide the search path, and that is nothing but the name of a directory. That's it. That's it. So that is how. So let me come out of this. For example, how you will modify the same program. So for example, /a.out, if I now execute it, parent process will create one child process, and now parent is waiting for child to finish. Then child gives some hello kind of a message. Now it wants to execute cal command. Cal command is executed. Remember, this cal command is hard coded in my program. It is hard coded. So for example, I use here. Right. Now, can we modify this program such that I'll provide the command here. So /a.out and say, for example, cal. So it will execute calendar. I'll provide, say, ls. Okay. So it will execute ls command. Maybe I'll execute commands, say, for example, cal and -3. So what happens with -3 is it displays calendar for 3 months. Let me cal -3. See, this is the previous month, this is the current month, and this is the next month. So now command is cal -3. So actually what is happening? Cal is name of executable file and -3 is argument. Now how to implement this kind of stuff? So for that you need, for example, anyways we aware that these will be available in argv here. So we can pass those to argv. Let me delete this. That thing is possible. Okay, so let it be for your homework. Now let me move to the presentation part. This part I already explained. Fork exec. Now this diagram is important. This diagram is important. Okay, so so one parent process is already executing. That executes fork. Now there are two paths. This is one path and this is second path. Okay. So fork. Now one path is for a parent, and what parent typically does is it is waiting for child to finish. So with fork we are getting two ways of executions. Okay. And here both are combined together. So this is typically called as join, Join. So fork creates two paths and join combines these two paths. Got it? Now the execution of child is very simple again. when fork creates a child, we'll replace the in-memory copy of just child process with exec. Even though exec is just mentioned there, I already mentioned exec is not a single system call. It is set of family. Got it? And like for example, execl, execl, cvp, something like that. Whenever that child process finishes, now these two paths will be combined together. Merging of two path happens here, and since then again we have a single path where parent will continue. Now you can imagine how the terminal is implemented. This is exactly the same way. So for example, whatever the shell we have, let me share my terminal here. Can you see the terminal? Okay. So whatever display, you can dollar mark, you can see this dollar mark, right? Now this dollar mark is my prompt string. So if I just press enter, say I am getting that dollar mark. Anyway, you can modify this by modifying the value of PS1. There is one environmental variable called as a PS1. Okay, so you can modify the value of that. Very important. I want to explain how this terminal works. Right. So for example, you can imagine like you have executed one program which has just displayed dollar and it is waiting for input. Okay, let me give the same example. Say cal. When I say cal, nothing is happening. When I press enter, which is the end of input, when I press enter key, that is end of line, end of input for the program bash who played that dollar. Okay, maybe I'll give anything. Actually, doesn't matter. Okay, so for example, another command say ls fork.c -l. Now purposefully I selected both the things. ls fork.c -l, where -l or -el says long listing. It wants long listing. Say for example, let me use fork and etc. Something like this. Now my line contains ls, then fork.c, fork_exec.c -l. Okay. Now it is just the input line, and you can read a single line separated by space. You can go with the get line function also, which will read complete line including. So it is just a string, right? Now when I press enter, what exactly happens is, say, it says -l no such file or directory. Okay, that means I need to give it maybe at the beginning. This is the command ls -l fork.c fork_exec.c. Now see what is the meaning. Because I use -l, I got the long listing. If I remove this, it is just name of the file. Fork.c is there, fork_exec.c is there. But when I use -l, so actually -l is not name of a file. If I use it at the end, it will consider that as the end of name of a file. But here it says it is option. It is one of the option for ls, how ls should work. And these are all arguments. But programmatically, all four are also arguments. So what this shell does is, whenever you press enter on input, it will try to understand what is the name of command. Now, say for example, if I give command something like a, it says command not found, right? So a b b b c c c fork.c. No, actually don't found any command here, right? But with ls hyphen l or say fork.c, or maybe a b b b c c c and fork.c also. Now here you will find that it is actually working properly with AAA, BBB, CCC files not found, and this fork.c is available there. So whenever you give input to your shell will first upon identify first parameter as a name of executable file. And because we have just given the name of file, it will consult the path environmental variable. So it will try to find. Like for example, when I just given A, B, 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 C, 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 or just A, then it says command not found because it tried to find out a executable file in my path environmental variable, which is not available there. Then this B, 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 C, 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 and fork.c, these three things will be arguments, rather command line arguments for the command A. Exactly same thing is happening with this one. So ls is name of executable file. Now, last time I guess mentioned, you can look for the location of any executable file using where is. So if I say where is ls, it says /bin/ls. And /bin is part of path environmental variable. So it identifies that it has to execute the ls command. Then -l will be taken as a parameter, command line argument, AAA is next command line argument, BBB is next command line argument, CCC is next, fork.c is the last one. Now it will try to execute ls on all these. When it tried with A, it says no such file or directory. Same thing for B and C, but fork.c is available there. So long listing of that file is displayed here. Now interesting part is, what do you think? My very, very simple question, or rather let me put that question on poll. So poll, and let me clear everything first of all. And my next question is, now does okay, now I just given the question there. Does shell creates child process? So respond to this. It is no, yes, and maybe. Last 15 seconds. 10 students are saying no, 45 students say yes, and 23 students maybe, 28 have not given the answer. Anybody who is saying yes, can you explain how you confirm that shell creates a child process? Anybody? Just unmute you and you go on talking. Out of 45, anybody? Because see that is the correct answer. My question is, how do you think it is correct? For each and every command you execute on shell, actually shell creates a child process, and then that child process executes the command. Okay. So correct answer is yes. Shell creates the child process, no doubt. My question is how you will confirm that? Anybody? If we enter tree command, it displays. Somebody is putting that answer on chat. If we enter tree command, then it displays the tree. That is fine. But the question is, for example, here if I fire the ls command, my question is very simple. For this ls command to execute, does shell creates the child process specifically for that ls? Answer to this is yes, it creates ls. See, reason behind that is very simple. How this ls will be executed? There is only one way to execute ls, and that is by making use of exec, right? And if exec is used, it replaces the in-memory copy. And if you don't create child, then what will happen is the shell will be definitely terminated. Because once ls is executed, say I'm giving next command, clear, next command, cal, next command, date. So actually once it finishes first command, it waits for input, right? It waits for input, it accepts next input, and then it executes it. Again, it waits for next input. If you replace in-memory copy of shell itself, then this behavior won't be happen. This is wrong. Exec is done, whatever you that will not be executed. So it is like an infinite loop. It is like an infinite loop in which what it does is it accepts the command, it creates the child process, the command is given to the child process executes that command. Once child is finished, it will wait for next input. That is the next command. That is how it works. That is how it works. Got it, no? So this is very simple thing. So when the child terminates, then only shell displays the prompt again. Okay. I don't know. It is answer or question? Priyanka Talwar, you mention on chat that when the child terminates, this is the answer. Okay, then only shell displays the prompt again. Exactly, because if it don't display the prompt, then definitely there is no pair. That means it is very simple thing. When child is executing, parent is waiting there. You're getting it, no? When child is executing, parent is actually waiting there. But anyways, there are other aspects also. For example, we can execute the command in background. That thing is also possible. Okay, so anyway, that part we'll see later. So let me stop sharing this. coming back here. So this is the typical diagram for shell also. So for example, if you are supposed to write a program to implement your shell, definitely you can follow the same diagram and you can write your own shell there. That is possible. So that is the creation of process. Let us move to the next. Now the same program we already saw there. Fork, if it is less than 0, it is error. If it is equal to 0, then there is a child process. And if it is a parent, parent is waiting. So parent usually waits for completion of child. This is typical flow on any Linux and Unix, even Mac. This is the case in case of Windows API. On Windows operating system, you need to make use of this one, windows.h. I don't know whether you've gone through VC, Visual C programming. Yes, anybody can put on chat. Have you gone through Visual C programming? No. Okay, it is not there in syllabus, I guess. Fine. So, like this is a program writing style. They don't actually call it as the pointer, but they call it as a handle. Okay. Vaishnavi Patil, mute yourself. Okay. So there are, say for example, here you can see, I just highlight by pi.h process. So that H stands for handle to that process. Anyway, just Windows API, like from windows.h, steps are again same, create the child process. So create process is name of call for that. You give command to execute that. Okay. And parent waits for completion of child. And once that is finished, it will close all the handles required there and then it continues. So actually, no, process and threads, both are supported on Windows also. But the programming language you need is VC, Visual C, not Turbo C on Windows. Now process termination, two types of termination. Number one, the process calls the exit system call once whatever the assigned task for your process is finished. That process will call this exit system call. Till then, the parent is actually waiting for child to finish. Once child is terminated, all the resources allocated for that process will be deallocated by the operating system. Like process creation is allocation of processes. So whenever process is finished, then it will deallocate the all this. So operating system actually deallocates it. Second way of termination of process is by the parent. So parent may forcefully terminate the child. I am saying forcefully. Okay, and for that the abort is the system call. Now try to understand exit and abort. Exit will be called by the process itself, whereas abort it will be by it is like it will send the signal. So parent will send the signal to the child process saying that stop your execution. So this is forceful termination of child process. Now why to do so? Why parent forcefully terminates the child? Possible reasons are mentioned here. Maybe child has exceeded on whatever the resources allocated. Maybe whatever task is assigned that is no longer required. Or maybe because parent itself is exiting operating system, don't allow child to continue. Like in case of Linux, it is allowed, but maybe operating system design is something like this. When there is no parent, there should not be child process. So for these multiple reasons, now I can say two types of process terminations. First one is normal termination. Whenever the task assigned to the process is finished, then that is a normal termination of a process with exit system call, and process itself call that exit. Whereas what is abort? Abort is whenever parent want to terminate the child process forcefully. Okay, so that is what the abort is. One thing is still missing here, like in case of Windows, we saw the creation of process. POSIX threads are also there. I don't think we can write it right now. Let us continue first upon the termination. Okay. There is question. Please explain exit again. Okay. Say it is something like exit is if you are executing one process, some task is assigned to that, and that task is finished, right? Then that process says exit. It calls exit system call. That is the reason I mentioned it is a normal execution termination of that process. Okay. So exit, I can say. Whereas you do something like you and your friend are actually talking with each other on the phone, and whenever you finish your talk, usually there is like handshaking kind of a thing. So for example, we say okay bye. So both agrees on okay bye, and then we terminate it. But it may also happen, maybe because of network problem or because of anything, it is terminated. Okay, so I can say that is abnormal termination. Here, in case of processes, child cannot terminate parent, but parent process can terminate the child. So that is abnormal. So for that, abort call is used for that. Now, next thing. There are few operating systems, as I mentioned, for abort. They do not allow child to exist if the parent is terminated. Okay. So in that case, if parent process is terminated, automatically all the children must be also terminated. And this is basically the cascading termination. So for example, there is a process, parent process, which has got one child. That child process also got one more child. So like that is a grandchildren for the original parent process. If parent itself is terminated, all subtree below that will be terminated. Okay, so this termination definitely will be initiated by the operating system. This typically don't happen in case of Linux, because if parent expires, then that will be taken by init process. Okay, parent process may wait for termination of child process. It is may, that means it is not mandatory, right? The same call we saw there, wait ampersand status, and then it returns the PID also. Even if you don't want to work with PID, you just say wait and ampersand status. Even if you want to wait for specific process, then there is a wait PID, a slight variation there in the system. Now there are two important things, and this is really asked in most of the aptitudes. What is zombie process and what is orphan process? Now try to understand this. If no parent waiting, process is a zombie. And if parent terminated without invoking wait, process is an orphan. Now, in second case, without invoking wait, and here what I written is did not invoke wait, both sound same. If no parent did not invoke wait, and if parent terminated before child without invoking wait, what is the difference? Like this one is called as a zombie process, and second one is called as the orphan process. Do you know what is difference between both? So let me go back to the code window. Yes. For example, हा आपला कालचाच last time's program आहे. So for example, I created child process here, right? Now, if I don't give this wait, I just comment out it. Let me save it, and now I will try to execute this program. So I'll compile this. So clang fork.c and execute it. See what happened. I got the prompt, and after that I got some output. So see, when I executed it, it says I am parent process with PID something something. Parent is waiting for child to finish. Ha apla just messages hota. Actually, it is not waiting because I commented that wait call. It said child finished with status 0, which is actually not true. Why it is not true? Because parent is actually not waiting. And when it says child finished, after that actually we are getting output from the child process. So when child says I am child process with PID something and PPID 1, this is wrong. Because what I expected here is PPID should be 12707. That should be great. But it is not here in this case. Okay. So here when it says I am child process, here actually parent is terminated. So because parent is terminated, still child process is alive, and init process becomes new parent for the child process. And that is the reason PPID is equal to 1. Now such a process is called as orphan process. Meaning of that is meaning of that is parent is not at all waiting. So we have not invoked wait, and parent is terminated. That's it. Okay. Whereas what will happen if I put something like sleep for 20 seconds. Sleep for 20 seconds. Let me save it. And then again I'll execute. Remember the previous example, there is no wait. In this example also there is no wait. Just let me save it. I'll go to the terminal, compile it, and run it. Now have a look here. See, child has finished. Still parent is waiting because I just invoked 20. That means parent is alive. After 20 seconds, parent is finished. Yes. Now the is when child has. Do you think that child process is completely removed from operating system? Because parent is still not finished. Parent is doing some other task, right? So parent is not finished. In previous execution, parent is finished before child. So child process becomes orphan. That is very straightforward thing. But in this example, parent is still not making use of wait system call, right? So my question is, when child process says done, whatever that execlp calendar command is there, when this command is done, do you think child is automatically removed? Answer to this is no, it is not removed. And reason for that is again very simple. For example, after sleep, if I put something like wet status, after sleep of 20, if I put this wet ampersand status, meaning of that is parent is busy doing something for 20 seconds, and after that parent want to see whether my child is finished or not, and if finished, what was the status. So actually child has taken say around 3 seconds for execution. After 3 seconds up to 20, so around 17 seconds parent has to child has to wait there. Why to wait? Just to convey what was the status when child process finished. So child do not have any task to do there, but still it is waiting, just waiting to convey its status to the parent process. So those 17 seconds, in this example, the child process becomes zombie process. Any doubt in this? Zombie and orphan. No parent is waiting. Fine. Parent is not waiting, so they have not invoked wait, but parent is alive, right? So till parent is alive, the child process has to wait for termination just to convey the status. So the child process do not have any work to carry out. So that is a zombie process. Whereas if parent itself is terminated before child, that is fine. The process is called as orphan process. Any doubt in this? Any doubt? Fine. So today we stop here.